Hey guys, Algebra 2. Today we are going to rationalize denominators. So what that means is we're still going to be working with radicals that like we've been doing, and we'll be simplifying them. Today I'm going to try different means of notes. Instead of doing them on my whiteboard, I'm just going to write them on the notes. And then I want you to tell me which one you prefer. And I can always do which one you prefer. They're both about the same for me.
So when we work with radicals, we don't want a radical in my denominator. So we have to get rid of it. And the way that we're going to get rid of it is we are going to multiply by whatever we need to break it out of jail. Remember, we've been kind of talking about that. So here, notice I don't have a number, which means that it's an implied 2. So I need 2 3s to get this out of jail. So what I'm going to do is I'm going to multiply the bottom by the square root of 3, because remember, I need 2 3s. I have 1, which means I need 1 more. And then since I multiplied the bottom by the square root of 3, I have to multiply the top by the square root of 3. Now, once I've done that, I'm going to just multiply across, just like I've been doing for radicals. So the square root of 2 times the square root of 3 becomes the square root of 6. And that's going to be over the square root of 3 times the square root of 3 is the square root of 9. Now, we know that we can take the square root of 9. The square root of 9 is 3. So this becomes the square root of 6 over 3, because the square root of 9 is 3. And this is our answer. I can't take the square root of 3 out, and I can't simplify it any farther. So this is my final answer. What we've done is we have looked to see how many more 3s I need to break it out of jail. I've multiplied by that many, both top and bottom. Then I just multiply across the top, and then I would simplify if needed. Let's look at number 2. So for number 2, I again have a square root. Notice, since there's not a number, that means that it's the square root. That means that I need 2 of everything to break it out of jail. I only have 1 of everything, so I'm going to have to multiply it by 1 more. Since I need 2 of everything, then I have to multiply it by 1 more. If I do it to the bottom, I have to do it to the top. Put my little multiplication signs there. All right, so now we've been multiplying. We know how to do this. I'm going to multiply everything inside. So I don't have a number, so that means it's just 5. I have 1x here and 3 here. So I have x to the 4th, and I have a y. And all of that is over. I have 5 times 5, the square root of 5 times 5. And I have x squared, y squared. Now, one more thing that I have to do is I have to simplify. I'm going to rewrite this down here so that we can see what I'm doing. All I'm doing is rewriting this. I'm not doing anything else. So in order to simplify this, I'm going to rewrite this. Equals. I'm going to rewrite this so that we can see what we've got. I have the square root of 5, and then I have 4 x's. 1, 2, 3, 4, and a y. And then on my bottom, I have 5 times 5, 2 x's, and 2 y's. Remember, when I don't see a number here, that means it's a 2. That means I need 2 of anything to break it out of jail. I need my bottom to disappear. I need my radical to not be there. So I need to make sure that I have 2 of everything, which I do. So I've circled what I have 2 of. Now I'm going to rewrite it. Anything that's circled gets to come out of the radical. Anything that's not circled has to stay in. So this becomes x squared, because I have 1, 2 groups of x's. I don't have anything else that I can take out on the top, which means that it stays inside the radical. Now that is over. I have a 5 that I can take out, I have an x that I can take out, and I have a y that I can take out. So I have one more thing to do, and that would be that I have an x squared on the top and an x on the bottom. Remember, x squared means that I have two x's, so I have two x's up top and one x on the bottom, meaning I can take one of those out. So I would simplify that to x square root of 5y all over 5y. So what we have to do is we have to multiply the bottom by enough to get rid of my radical. And if I'm multiplying the bottom, I have to multiply the top. Then I just multiply across and simplify like we've been doing. And you know how to simplify. This is just one more step. So this is the cube root, and we can rewrite it. Whenever we see a fraction written like this, I'm going to rewrite it as the cube root of 2 over the cube root of 3x. Now, how many do I need to break it out of jail? You should see that I need 3 to break it out of jail. I have 1 3. How many more 3s do I need? Ideally, you would recognize that I need 2 more 3s. 1, 2, 3 3s will break it out of jail. I have 1x. How many more do I need? I need 2 more x's. Whatever I multiply the top or bottom, I have to multiply on the top. So I'm going to multiply this. I'm going to have to rewrite it down at the bottom. So 2 times 3 times 3. I'm just going to rewrite it like that. And then I have x. And remember, it's a cube root. So all I've done is I've multiplied my 2 times everything inside my other radical. And that is over the cube root of, I have 3 times 3 times 3. I like to keep all of my numbers together. And then I also have x times x times x. I like to keep my numbers and my variables together. It's a little easier for me to see. So the last thing I have to do is I have to simplify. So because of this 3, that means I need 3 of anything to break it out of jail. So I'm going to circle groups of 3. I don't have anything that I can circle on the top. So I'm now going to 2 times 3 times 3 is 18. That stays inside my radical. And I have 2 x's. I can write it as x squared. Notice I don't have anything left inside the radical, and that's exactly why we did this. So I have one group of 3, and I have one group of x. So that's my answer. No radical on the bottom is the reason we did this. So let's look at our last problem. I have the cube root of 4 divided by the cube root of 6x. So because of this 3, that means that I need 3 to break it out of jail. I have 1, so how many more do I need? You should recognize that I need 2, so I'm going to write 6 times 6. And I have 1x. How many more do I need? I need 2 more x's. And if I did it to the bottom, then I have to do it to the top. 6 times 6x, x. All right, so now I'm just going to multiply across the top and multiply across the bottom. So I will have the cube root of 4 times 6 times 6 x, x. All I've done is written what I've multiplied, 4, 6, 6, and x's. And I'm going to do the same thing here. I have the cube root of 6 times 6 times 6, these two. Remember, this is being multiplied. And then I have 3 x's that are being multiplied. This x times these 2 x's. So 4 times 6 is 144. I'm going to put that as x squared. and this is the cube root. And then I was able to take out a group of 6 and a group of x. Now this 144, we're going to have to prime factor. And the reason we're going to have to prime factor is because there is something that I'll be able to take out of there, but I'm not positive what. So remember, we have to find groups of 3. 144 is even, so I'm going to prime factor it to 72. And then because it's even again, I can take out another 2, and that's 36, and 2 and 18, and 2 and 9, and 3 and 3. So now I'm going to circle groups of 3 because of my 3. So I have a group of 3 here. I don't have anything else that I can take out. Also, x squared, 2 is less than 3, so I can't take anything out there. But I can reduce this radical. So it becomes 2 cube root 2 times 3 is 18, x squared all over 6x. Now, one last thing. You should recognize that 2 and 6 are even numbers, which means that I can take a 2 out of both of those. When I do, this becomes the cube root of 18x squared. 6 divided by 2 is 3x, and that is my final answer. So what we're doing when we're rationalizing is we are going to multiply by how many more we need to break it out of jail. Whatever we do to the bottom, we need to do to the top. And then we're multiplying. You've been multiplying. We multiply what's inside the radicals and then what's outside of the radicals. And then we're just simplifying.